Okay, I'm back. I will, I just want to finish the missile. Okay. So now we're going to add a guided missile. So right now it's not guided. Okay, so let's make the missiles guided. So how do we do that? Well, piece of cake. So if you listen to a PC speaker, the sound is well, anyway, what we do for sound is if you call noise or you call sweep, then it creates a task. Shut up, bird. It creates it. You set a min frequency and a max frequency. Shut up, bird. It creates a. Shut up, bird. It creates a task that is in charge of that noise. So it does random numbers for white noise. God, I hate that bird. Anybody want a bird? Okay, so now we're going to do a guided missile. So let's put a angle on the missile. So missile, this will make it modular. By that I mean well, angle. We should say thrust angle. Thrust angle. Okay. So we have a thrust angle, and oh, you know what? It can't be modular. Do you know why? Because the differential equation engine looks ahead and behind the time just take my word for it. The engine would okay, so we're going to look for targeting. I guess we'll do that. We should do a subroutine. So let's find the target mass. we want the ship. Okay, so might as well do a my mass. Target missile. Ship. SP. If exploding. Ah, shit. If we're drawing, let's look for how we. If not exploding, that ought to be good enough. Otherwise, I just wanted to, anyway, not exploding. Okay, so the standard. Gotta hate that bird. Shut up, bird. Result equals null. You want to do the, no, not the nearest. We want the one most directly in front. Okay, so let's see, dot or cross, shut up, bird. Dot or cross product. We want dot product, so we're going to, we have a technique for CD3, P count, P1, P2. God, I hate that bird. Okay, so we have, I could tell you what this is. Let's see. So the three points that we use for direction are, we have, there's a triangle, and we add the two together, and that gives us the average. And once we have the average, that's the center line. So we subtract the two. So P is the velocity vector. P is the velocity vector for the ship. Not, it's a unit vector. And result is going to be, so we want to find the nearest. What do we want to find? Some combination of distance and the nearest one that's in. How about we make a sector, and then take the nearest one within the sector. Oh, we don't want the ship, we want the missile. You idiot. Well, this is easier. Or is it? So now we want to subtract missile P front, missile P back. And we can say unit on that. So I don't have operators from C++, operator overloading, so, and we don't really have classes. Anyway, front, back, most times it's not. Oh, we do want a ship SP. Not exploding. Go through the masses. I think we want to see if it's active or something like that. Let's find overlap and see if it I was checking if it was inactive. Okay, never mind. Okay. What target get? Do we want a mass or a ship? I guess let's do a ship. That's kind of cooler. That's kind of cooler. Okay, missile. So it's kind of bad to use. Oh well. P1. We do need a distance. Let's distance. First, no, we want the vector towards the ship. From the front to, no. From the mass that's a mass.x. Okay, so we put this in P1 and now we want the dot product. Let's make a score that's equal to dot product. We want it. Let's make this unit vector. No. Yeah. Okay. Actual. Shut up, bird. Shut up, bird. Okay. So we're gonna let's let's make a condition. Shut up, bird. Let's make it. Shut up, bird. Let's make a condition. Shut up, bird. Let's make a condition. Okay, so D3 unit address P2 D3 copy address P2. To understand how these work, address P1. So we just made a unit vector out of it, and then if let's say dd equals d3 dot 1 2 dot product. Okay, we can even jump ahead. If what is this equal to? M1 M2 cosine angle. Yeah, that's what it is. Okay, address P is our velocity vector, P2 is our target vector, and if minus pi, we have pi, check this out, pi divided by what do we want, about pi over 2, pi over 4, how about pi over 8, minus pi over 8 less or equal dot less or equal pi over 8. Okay, so this, God, I hate that bird. This gets us in the door, and then dd equals d3 distance no, we want the norm squared. Norm squared of P2 P3 P1 norm squared of, well, we already took the square root when we made it a unit vector. That's a shame. If dd less than, once you've God, I hate that bird. Once you've programmed for a while, you develop patterns that you repeat over and over. Okay, I think we're done. So subtract front from back. Once you've programmed for a while, you develop patterns that you just repeat the pattern, or you just, okay, so temp. Okay, now target get missing parenthesis D3 unit. I hate that bird. What? Okay. Target get ship. So if it has been launched, then we have to guide missile. Temp SP equals target get temp MI. Okay. Now let's set the thrust angle. So we are, there's the front to back. Let's see. How do we want to do this? The spin of the, you want to prevent spinning. Just do it. What do you, don't dawdle. Okay. So is there a P1 and a P2? Yeah, P1 and P2. If fuck that bird. Fuck that bird. D3 subtract P1. We want to do address temp SP P0 dot X comma front. Okay. And now we want the dot. The error angle, the angle of error is going to be the dot product of that's theta. Oh, we want state. Damn it. Did we use state for target get? I don't think we did. Front state X. There. The reason is because we're in the derivative. And is that a dot, or is that a, yeah, it is. No, it's not. In a normal simulation, time flows forward uniformly. When we're doing this derivative function, time does not flow forward constant uniformly. Okay, that was your imagination. Okay, so we should set the explosion. We should be able to trigger an explosion. Now that's kind of tricky because, okay, so it doesn't evaluate in order all the time. Sometimes it does time out of order, and so it's actually pretty tricky doing this. Let's call this error theta. Error theta. I like that. Theta error. How about theta error? Theta error. Okay, so theta error equals d3 dot address p comma address p1. So this is cosine, and well, whatever. Theta thrust equals clamp why do I call it dV? What the fuck? dV low high. That makes me furious. Why do I call it dV? That's like drive. What the fuck? It should be just D. I. So, clamp I64, U64, and then there's another one. Okay, so escape out of here. Escape, and we want to go to clamp. Oh shit. It's an external. Oh, it's a assembly. Oh, we don't have variables in the assembly. Okay. That's not it. Clamp number. That's not what we use. We use D. Why? Fuck it. Control Shift. Why is this not in the Control F, number D, rename local variable. Okay. So, say what? Clamp. Oh, well, that's kind of bad. D. Those should say number. Okay. Okay. So this is D. And clamp. These should say number. Number. Oh, extern. It is. Okay. Clamp. Low, high. Low, high. Okay. FD. Clamp by 64. Okay. So these have no opinion. Well, I got fancy. I got really fancy. Okay, now quit out of there. Go back. Let's go back to okay, I knew that. Theta error, comma, pi divided by 16 minus pi divided by 16 pi divided by 16. Now we're going to okay, so this is the thrust angle. Now what do we do about this? We make a vector. We do polar coordinates. So D3 unit so that was out the back, and so it's pointing forward. Okay. D3 unit. D3 add equal. All right. P EQU. It's a unit. What are we adding 2 units? That should. What are you doing? You want to add to the tip of it. And so momentarily I've having a crisis. So you have a vector, and if you want to thrust at an angle, you want to add to the angle. And that is half. That's not right. What do you want to do? You want okay. Have a vector. Vector, and you have theta, then oh, I know what. We want to rotate by an angle. Okay, I know this operation. Okay, this is, what's the easiest way to do this? Okay, so what you have to do is, we don't want to do this. We want to do a rotation, and so P dot X. No, you don't want to change them. You don't want to change them while you're doing it. P2 dot X is equal to bird. God, I hate that bird. God, I hate that bird. Shut up! Okay, does this stay as a unit vector, or did we change the magnitude? first of all, one of these is a negative. Oh, X. Well, let's see if we square this. I don't know. Let's just you want to make it a unit. You want to make it a unit. How could it be? We're rotating by an angle, so it should stay the same magnitude. If we did this right. Fuck it. Let's see. Cosine, cosine. How about the other answer? Okay, we want an anti-spin. So what do we do about that? We want to take the spin, which is the cross product of the velocity at the top with the unit vector of the length. So we want the velocity at the top Okay, that's not a problem. We can actually do that. So you take D3 cross product product D1, D2. Okay, product. So P1 P crossed with the velocity at the top. Wait, we want the velocity at the top minus the velocity at the bottom? I think that's what we want. We want the velocity at the top minus the velocity at the bottom to get the spin. Yeah, if they're both moving, then you don't want that. So we subtract into P1 dx dt. Oh, hold on. The missile velocity. Dx dt. Comma. So we velocity at the top minus velocity at the bottom. Take the cross product with, wait a minute. What if it's just the, And we want the cross product with the and then we want the magnitude. So thrust error minus D3 distance norm, D3 norm, dress P2. And as I don't know if this is like sim structure, but if this is like sim structure, let's see. Okay. Do you think, God, I hate that bird. Do you think we can slow this down? I don't want to slow it down. Velocity at the top minus velocity at the bottom. Cross product. It's an absolute value. Is that what we want? No, we don't want an absolute value. Holy shit. Holy shit. How do we deal with this? Distance? What the? Shut up, bird! Okay, see. Shut up, bird. Okay. D omega. We don't have an omega. What do you call that? We don't have one of those W's. Let's just use W. W is, it's not DW, it's W. W. Might as well call it W spin. How about D theta spin? Yeah, let's call it that. How about just D theta? Okay. So D theta is omega. So if P2 dot C less than 0, theta equals minus theta. Damn it. I hit Okay. You son of a bitch. Alt backspace. Alt backspace. Alt backspace. Alt backspace. Alt backspace. There it is. Okay. Okay. D alt that equals that. D equals minus. Okay. Fucked up. Okay. Something is not right. Shut up, bird! P2, P2. Z. Okay. Fucking pissing me off. Okay, we have too much anti-spin. They're going straight. 0.001. Direction's wrong. This anti-spin is let's open up the you want to open up the target right now. No, I like that. Let's keep that. What if the dot product is oh, never mind. The anti-spin definitely works. Okay, let's say 10 times the error. We want to not target ourselves. So how do we? Let's turn the target green. Let's change the color. Oh, let's keep that as a feature. Let's keep that as a feature. If targeted, how are we gonna? Let's missile. Let's put a ship as the target, and then oh, we can't. Let's see. Eastern ship class. Ship target. Okay. So we're going to go through the ships. We're going to go through the missiles and see if any of the missiles have us as a target. And so how about let's just plot a X on the targets. So missile route active, launched, not exploding, launched and exploding. Okay, so down here, shot route lasers. What if we target even when it's not active? You want to do that? I guess that's what we're supposed to do. So, if active. Okay, if active. Guide missile. SP. If active. Launched. So if active. If launched. Control Shift L. Again. If SP. Active. SB. MI equals target. I don't know when I started doing this. Okay. So, target. Okay, so active. Else. Target. No. Now we plot the targets. If target temp SP equals target. Let's see. Color equals light red. DC. Pen width is 2. GR. Circle. DC. Maybe it's BP. I'm going to do .z just to be interesting. No, let's just do 0. Missing expression and what are you talking about? Oh, so I see radius, of course. Forget the radius. Oh, look at that. Well, that's fucked up. Okay. So we want to exclude the owner. Okay, now we look for make a new missile. Ship. Owner. SP. Target. If not exploding, and this P not equal owner. Okay. Well, the dot product is all cluster fucked. Okay. P sub I, SP masses, front state X. Front from back, subtract P. We want dot product. There, it's large. Oh, we want cross product. Isn't it just 90? It's like 90 minus. Cosine and sine. Z. Oh, fuck. So it's large if it's in the correct spot. We want cross product. Okay, fuck it. We want cross product. Just P1. T3 norm less than 8. Okay, fuck. We want, no, we don't want that. If P1.c greater or equal to 0, and norm address P1. That's better. Why is it targeting the back? There could be. Do we have a bug? Okay. We do one. It's one sine of the angle, isn't it? Sine of the angle. Are you serious? Do we have to fucking do another? Do we have to do a dot product as well? What the fuck? The cross product. Cross product. What? That's worthless. I guess we have to say if D3 dot address P2 if the dot product greater than 0 and the cross product. That's fucked up. Okay, we want some anti-spin. Okay. First, let's pretend this is sim structure, and this. This is probably the same issue. It's over there. That. Okay. No, I think. Okay, the anti-spin is working. Let's see if the error is working. Okay. It curved away. Okay, we need some anti-spin. Okay, first of all, do you reverse the dot? That's the cosine. Okay, never mind. Okay. Okay, we have too much anti-spin. Not enough anti-spin. Let's put less anti-spin and more error. We need more anti-spin or more error. What about the angle of the error? The clamp, 16. Let's change it to 8. 8. It's curving the wrong way. I think it's the spin. Let's put more error. There's too much spin, anti-spin. Too much anti. Less anti-spin. Is the error the wrong direction or not? The wrong direction. Okay, you know what we're going to do? We're going to put L and R. Let's put text. Label. Missile. Okay, what is the answer? Left is 1, right is 0. Left is 1, right is 0. Left is 1, right is 0. Okay, now okay, left is 1, right is 0. We could color them, but we're not going to. We are going to text. X, Y. Oh, it's a character. Damn it. Let's one, two, three. Let's just see. 5. 1, 2, 3, 4, 5. Okay. And string copy. String copy. Right. Okay. GR print. Print. Okay. Let's Okay, let's okay. These things fly like shit. I can swear it's the wrong direction. That's better. There we go. Now we're much better. A little bit less. Okay, so if it gets within a certain distance, we explode. Spire shot, missile. If not exploding, okay, F-64 DD. If temp MI target DD equals D3. distance squared temp mi p front dot x comma temp my target p 0 dot x address if not exploding equals true. Else D equals 64. It is not exploding. Distance squared. Why don't you just do distance? Fuck. Distance. If target distance is less than 20. If not exploding and distance is less than 20 or TS is greater than fuse time 30. Oh, it's not targeted anymore. How about it doesn't target after you launch? If launched, else Okay. Okay, that's better. Okay. Spire missile. Let's do DD. DD. SQR. 20. 20. DD. It did not go up. 25. What if it's one of the other? Okay. Space one. What do we have? Left. Hello? Let's go ahead and go off of all launched. This is not too bad. DD equals max F64. Where's I? You're not using I. Is that correct? Yeah, we are not using Spire missiles. Okay, now we go to the number of masses. Masses. SP number of masses. Okay. Okay. If target. Best. DB. DD, P front, P supply. If DD less than SDD. DD. SP. Fine, let's just call it target. circles. Okay. Maybe. Okay. We're just wasting time. about divided by error? Error. Absolute value of error. If error is small, is small, we don't turn very much. Well, that's stupid. How about T, I don't know. Only if it has a target do we launch. Fire one missile. Not launched. Space one. So we're doing that, and we'll shut down.